Good morning. So today we're going to be talking about simplifying rational expressions. So we're going to have 4 steps. I know usually we don't do steps, but today we will. The first step is going to be to factor the numerator. Then, the numerator is what's on top. Then we're going to factor the denominator. And then we're going to find restrictions. What are restrictions? Restrictions are anything that makes the denominator equal to 0. We don't want the denominator to equal to 0, or else the rational expression becomes undefined. Remember, you can divide 0 by a number, but you cannot divide any number by 0, or else it's undefined. So you want to make sure, just like our domain and range, we say it's all real numbers, but x cannot equal. Here, this is the simplified version, and x cannot equal. So then finally, the very last step will be to simplify. So then we're just going to get rid of any expression that is on the top and the bottom. Let's get started. So in example 1, we have m plus 5 over 2m plus 10. So m plus 5, you can't really simplify. It's just m plus 5. And then 2m plus 10 has a GCF of 2. So we're going to take out 2, and we're left with 2 times m plus 5. So the only time that we can simplify is when we're multiplying. So here we have this whole expression, and then we have the same expression down here multiplying times 2. Because we only cancel out when we're multiplying, we can't just take out the m, and we can't just take out the 5. We have to take out m plus 5, because in math, this expression is all one term. It's all together. So when we cancel out m plus 5, we can only do this because m plus 5 is multiplying here by 2. When we cancel out, we're left with 1 on top, 2 on the bottom, and it simplifies to half. Oh, my restrictions. I'm so sorry. I totally forgot. So on the bottom, we look at the expression and we say, what will make this expression 0? Here we have m plus 5. So we know that m plus 5 is 0 when m equals negative 5. So we don't want m, actually that's m in this expression. We don't want m to equal negative 5, or else that would give us a denominator of 0. Moving on to our example number 2. Up here we have x squared minus 49. So we know that this is the difference of 2 squares. And there we go. We know that this is the difference of 2 squares, and so we are going to factor using the difference of squares. So we know that when we have the difference of squares, we split the squares, right? So we're just going to separate them. So x squared separated will be x and x, and 49 will be 7 and 7. So we know that because it's a difference of squares, one will be negative and one will be positive. we are going to put all of this over our factored 5x squared plus 36x plus 7. I'm not going to go over how to factor because by this time you guys have been factoring since Unit 2. If you need a refresher, please ask the sub or refer back to your Unit 2A and 2B notes. So when we do factor 5x squared plus 36x plus 7, we should get 5x plus 1 and x plus 7. So again, we can only eliminate expressions at a time. We cannot just take out the x or just the 5x or just the 1 because here we are subtracting and in these three we're adding. What we can get rid of are full expressions that are being multiplied by each other. So here we can get rid of x plus 7 because it's multiplying times x minus 7, and we can get rid of this x plus 7 because it's multiplying times 5x plus 1. If there was an addition or subtraction sign between these two expressions, even if this one's multiplying, I cannot cancel out this one if this was addition or subtraction. Looking at our expressions on the bottom in our denominator, we know that for x plus 7, it would only be 0 if x equaled negative 7. And then for 5x plus 1, we know that 5x plus 1 would give us 0 if 5x equals negative 1, if x equals negative 1/5. So we'll say that x cannot equal negative 7 or negative 1/5, but our simplified rational expression will be x minus 7 over 5x plus 1. I know it's getting a little bit harder, but as long as you remember that you can't eliminate an expression unless it's multiplying, you should be fine. So moving on, it's a little bit easier now. We have 6x squared times y. So we have 6 times x times x times y. Some of you guys can do this in your head. That is totally fine. Then with our denominator, we have two GCFs that we can take out. We can take out 3 from 3x squared and 9x, and we can also take out that x. So when we do take out 3x, we're left with x plus 3. So when we look at whatever's outside multiplying, we see that we can simplify 6 and 3, and the 6 will become 2 because we're dividing top and bottom by 2. And then these two x's can cancel out. And so on top, we're left with 2xy over x plus 3. And we know that the only values for x that would give us 0 in the denominator would be 0, right? Because if this was 0, everything else would become 0. And negative 3, because negative 3 plus 3 would give us 0, and that multiplied would make everything 0. So it can't be 0 or negative 3. Moving on, we need to make sure that we know the difference of what we can cancel and cannot cancel. So we're going to spot the differences because you can only cancel if the operation is multiplication. Underline it, memorize it, highlight it, write it on your bathroom mirror, whatever you have to do. You can only cancel if the operation is multiplication. If we are adding or subtracting and you try to simplify and cancel something out, it is not going to be the right answer. So here we have 3y minus 4 over y minus 4. This 3y, or this 3, is not multiplied times y minus 4. It's just multiplied times y. So because of that, this is all one term. So because it's all one term, this is a term minus 4. So I can't cancel out these y minus 4s. Here I can, Because this is 3 times y minus 4 over y minus 4. Because this 3 is multiplied and it's not part of the expression, I can cancel this out, and this would give me 3. Here again, 10 over 7 equals 3 plus 7 over 7. A lot of you guys will want to cross out this 7 and that 7 up there for cross canceling. You cannot do that because it is 3 plus 7. In our verses, we have 3 times 7, and that you can cancel out. We'll cross out these 7s and cross out this 7 and 21. And we see that that is true because 3 does equal 3. But we could only cancel these out because this top part had 3 times 7. Now let's put that into practice. So number 6, 7, and 8, these are our last 3 examples. In 6, we have x cubed minus 27. From Unit 2b, if you can remember all the way that far back, way back in December, we learned that when we have the difference of cubes, we need to write it as a difference of cubes. We know that 27 is a perfect cube. So we're going to rewrite this as x cubed minus 3 cubed. This is all going to be over, we're going to take out that GCF, 5 times x minus 3. Now we know that our restriction will be x does not equal negative 3, or else, positive 3, sorry. Because if it's positive 3, then this expression becomes 0, and that makes the denominator 0. So we're going to rewrite this. Remember, when we factor a difference of cubes, we cannot just say x minus 3 cubed. We have to say x minus 3 times x squared plus 3x plus 9. Again, I'm not going to review how to factor cubes because you can refer back to your Unit 2b notes. And then we have on the bottom 5 times x minus 3. We know that you can cross out x minus 3 and x minus 3 because they are multiplying times other terms. So what we're left with on top is x squared plus 3x plus 9 all over 5. Now, moving on to example 7, we have 42 times xy squared. So we're going to factor this out, and we're going to say 42 is 6 times 7 times x times y all over 18. Hey, look, 6 can also go into 18. So we're going to have 6 times 3 times y to the 5th. I'm writing this out this way because I want to show you how and where we're canceling out. Some of you can do it in your head, and some of you from Algebra 1 can look at this and automatically say that the y's cancel out because when you have like variables dividing, you're going to subtract the exponents. But some of you don't remember, and so that's why I'm writing it all the way out for you. So I know that 6 cancels out. By the way, our restrictions, what would make our denominator 0? Y equals 0. So we don't want y to equal 0. So we know the 6 cancels out. So do these two y's. And we're left with 7x over 3y to the 5th. And y does not equal 0. This is also part of your answer. This y does not equal 0. Your restriction is also part of your answer. So here, it should have been x squared plus 3x plus 9 over 5, and x does not equal 3. Now, again, we have x squared minus 49. Oh, wait. Number 8 is the exact same problem all the way back from number 2. So I'm not going to go over this again. You already know how to solve it from number 2. If you want to check on your own, now that you have the answer for this in number 2, you can always try doing it on your own without looking and check to see if your answers are correct. I hope I didn't go too fast for you guys. Remember, you can only cancel if there is multiplication, not addition or subtraction. And you cannot take out one term of an expression that's multiplying. It has to be the whole term or nothing at all. Also remember, if maybe the numerator or denominator is multiplication, but the opposite is addition or subtraction, you still cannot cancel. Both numerator and denominator needs to be multiplied. What else? Just remember the steps and you'll be fine. Factor the numerator, factor the denominator, find your restrictions, and simplify. I hope this was simple enough. And if you have any questions, please feel free to email me or ask your current sub. Have a good day.